This is lesson 11.3 about proofs and triangles. Okay, first, going over the warm-up, which you should have already done. You were supposed to determine which congruence test, if any, can be used to show the two triangles are congruent. So the tests that we have, just to remind you, are side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. So those are the tests that we have. So if it's not one of those, then we're not going to use it. So on number 1, we see that we have an angle followed by a side and a side. And that by itself is not a congruence test. But if you look and notice, it's also a right triangle. So because it's a right triangle, we have the option of hypotenuse leg, which the hypotenuse on each of those are the same and the leg is the same. So actually these are congruent because of hypotenuse leg. It also says to write a congruent statement. So you're going to write triangle, and you can say ABC or BCA or whatever. I like to do the first one in alphabetical order. And then it's going to be congruent to triangle. And so A is going to match which side or which vertex. And so it's going to be QPR. Number 2, we see that PO is congruent to itself. That's a reflexive property anyway. We see that these angles are the same, and then we see that these sides are the same, so we have a side angle side. So I'm going to say that triangle PMO is congruent to triangle PNO. Now, if you do a different order of, say, the first triangle, so if you did like POM, that would be fine, but you would do PON. And so as long as everything matches up, you can do it in whatever order you want. Okay, number 3, we see that we have an angle followed by another angle, and then a side. So angle, side is a congruence test. And so I would say that triangle ABC is congruent to triangle FDE. And then last is number 4. And we've got these two angles. Now, even if those weren't marked, I would know that they're the same because they're vertical angles. So that's one thing that you need to be able to recognize as vertical angles when you see it. So even if they weren't marked, I would know that they were the same, okay? And then I've got these two angles, and so I've got angle, and then there's a side included, so that'd be angle, side, angle, and that is a congruence test. So we're going to say triangle ACB is congruent to triangle DCE. Again, you could say ABC, but then you would say DEC. So it doesn't really matter, just however you want to do that. Okay, for the next problem, it says given the measure of angle C is 105. So the first thing I'm going to do is go in here and mark everything. So this is 105. The measure of BAC, so that's going to be this angle right here, is 45 degrees. The measure of angle BAD is 45 degrees. And the measure of DBA, so starting at D going to B and then A, is 30 degrees. Okay, so that's what I've got. And it doesn't tell us anything about the sides. Now, if you look at the picture, you might think, okay, well, I've got a couple of angles. Okay, I've got these angles, and I don't know the other ones. I do know, though, that this side is equal to itself, so I could use that in my proof. And so let's go and see how the proof is set up. So first off, it says given, and it's got 4 blanks. So I've got 4 things, so I'm just going to restate everything that was given. So the measure of angle C is equal to 105. The measure of angle BAC is equal to 45 degrees. The measure of angle BAD is equal to 45 degrees. The measure of angle DBA is equal to 30 degrees. So that's my given. All right, now the next thing, it says blank and blank. It says the sum of the angles in a triangle equal 180. So how would knowing the sum of the angles equals 180, how would that help me in this problem? So look at this triangle right here. I could find that angle right there, and I could find this angle right there using the fact that the angles add up to be 180. So get your calculator, and you can say 180 minus 105 minus 45. And so then you get that the measure of CBA is equal to 30 degrees. And then you're going to do 180 minus 45 minus 30, and you'll get angle D. So let me put, this is 30, and then D is 105. And so the measure, and so you could put D, you could also put ADB. Since there's no confusion, I couldn't call this angle right here B because it could be that one or it could be this one. So there's some confusion there, so you can't just say angle B on that one. But for angle D, there's only one angle D, so I could say the measure of angle D is equal to 105. Okay? Now, I've got this set up for you, and when we have that, it kind of helps map things out. One thing to make sure that you know is that just having the angles be the same, that's not enough. Angle, angle, angle is not a congruence test. It's a similarity test, but it's not a congruence test. You can have like a really small equilateral triangle and a really big equilateral triangle, and all their angles are 60 degrees, but that doesn't make the triangles congruent. So angle, angle, angle is not a congruence test. Okay, so I've got this mapped out, and it says for A, that's going to be talking about an angle. And so congruent parts have equal measures. So what were two angles that are congruent because they have the same measurement? And so just give me one of the sets of angles. And so it could either be the 45-degree angles or the 105 or the 30. And so you have to think about, well, which one do I want to use? Now, in the middle, it says reflexive property. What's something that we talked about with the reflexive property? We said that AB was congruent to itself. So AB is congruent to AB because of reflexive property. So if that's the side we're going to use, do I want to use the 105 if I'm using angle, side, angle? If I'm using angle, side, angle, I want to use the 45 and the 30-degree angles. So I'm going to say that the measure of angle CAB is congruent to the measure of angle DAB. That's one of my angles. And then I'm going to say the other one would be these angles right there, the 30-degree ones. So I'm going to say the measure of angle CBA is congruent to the measure. Oh wait, if we're saying congruent, we don't need to say measure. We can just say the angles. If it says congruent, you can just say the angles. Okay, and so CBA is congruent to DBA. And that's the same reasons we have right here. So congruent parts have equal measures, and you can abbreviate as long as it's a true abbreviation. So because of that, I've shown angle, side, angle, so my two triangles are congruent. So look back up at what it said to do. It said prove whether or not those two triangles are congruent. Well, we've just proven that they are. So I'm going to say triangle ACB is congruent to triangle ADB because of angle, side, angle. All right, let's go into the lesson. So in the lesson, it's just working through some proofs. And so I'm just going to talk out how I'm thinking about the problems. And so depending on what you're given and depending on how the proof is set up, you're not having to do any proofs from scratch. You're going to be given some information to do proofs, but you have to be able to think out the steps. So the first thing you always want to do is look at your givens. If there's not a picture, draw a picture. If there is a picture, label the picture. So I'm going to take my pencil and I'm going to label all of the things that I'm told are true. So it says J is congruent to N, so I'm going to mark those as being congruent. KM bisects JN. Now KM bisects, that means it cuts in half JN. So that means that this piece is congruent to this piece. It does not work the other way around. It didn't say that JN cuts KM, so I cannot mark the other ones. Okay, I cannot do that. It also says that JK is equal to 6. So in purple, that's what I'm given. Okay. If I go down to my proof, in statements 1 and 3, it already has my givens. So it says J is congruent to N. It says KM bisects JN. That's because of given. And then it's got a place for another given. That's going to have to be JK is equal to 6. Okay, so I've taken care of my givens. Now the next thing I'm going to do is I'm going to look at the picture and ask myself, I haven't even bothered to see what I'm trying to do yet. I'm just still looking at what do I know from the picture. So one thing that I know, and I told you this in the warm-up, you have to be able to identify it. I know that this angle is congruent to this angle because they're vertical angles. So that's going to come in somewhere in my proof. Somewhere I think I'm going to use that, okay? And so if I look down on my proof, ooh, look, they're right there. Vertical angles have equal measures. I've already found them, so I'm going to say that in here. So angle KLJ is congruent to angle MLN because they're vertical angles. Going back to number 4, and seeing what that says, because we kind of skipped over that. It says that JL is congruent to NL. So how did I know that they were congruent? How did I know that in the first place? It didn't tell me that they're congruent, but it did tell me that KM bisects it. So the reason I knew that they're congruent is because the definition of what a bisector is. Okay, we knew that if it was a bisector, it cuts it in half. That's what a bisector does. That's what it is. Okay, now I think I'm ready to look at what I'm trying to prove. It says we're trying to prove that NM is equal to 6. So I'm trying to prove this right here. I don't know that, so I'm not going to write that down because I haven't proven it yet. So I need to think about what do I know. So looking at my two triangles, this triangle and this triangle, do I know anything about those two triangles? Look at what we have. We have an angle and a side and an angle. So I actually can prove that those two triangles are congruent to each other. Now, if they were congruent to each other, then everything matches up. If they're congruent to each other, all of their parts are the same. So what I'm going to say is the next thing is I'm going to say triangle JLK is congruent to NLM, and the reason is angle, side, angle. So if I've got these two congruent triangles and their parts match up, then it would follow that these parts have to match up too. So if K, I can't see what letter that is, if JK is equal to 6, then the part that matches it is going to have to be 6 because they're congruent parts of congruent triangles. So what we are going to say in that one is we're going to say, okay, well, so JK is congruent to NM, and it's because of something called Cpctc. So let's talk about what Cpctc is. This is something that is a really great tool, but it's really easy to get it mixed up with how you're using it. So what these labels stand for, it's an acronym, and it stands for corresponding parts of congruent triangles are congruent. So that's where we get Cpctc. It's obviously a lot faster to say that than to say that whole thing. So a couple of things about Cpctc. So first of all, it's not a congruence test. Okay, so it's not like ASA or SSS. It's not one of those, okay? You can only use it after you have congruent triangles. You cannot use it if you haven't already proven or it's already been stated that the two triangles are congruent. So if you don't already know that the triangles are congruent, either you've proven it or it was given, you cannot use Cpctc. It will never come first. So that's a really important thing to remember about it. But once you've said that these two pieces are congruent, then that means that their measurements are equal. Okay, so remember that congruent parts have equal measures. Congruent parts have equal measures. And so there's our proof. So we have proven now that NM is equal to 6. The thing to remember about a proof is it's very split up into very small steps because we have to prove every single thing. We have to have a justification for anything. We can't assume anything. We cannot jump in and say, well, obviously that's true. There's no obviously here. You have to prove every single thing. And that's one of the things that people struggle with proofs. They don't want to say everything. And so that's something that can be kind of difficult. Okay, let's go to the next one, or the next part of the lesson. It does say at the bottom about corresponding parts of congruent triangles are congruent, and it just kind of says what I just told you. It's this reason is used to show that corresponding parts are congruent, and it can only be used after you have proven that two triangles are congruent. So for example, if you have already proved that these two triangles are congruent, then you could say that angle B is congruent to angle X because of Cpctc. Remember what these letters stand for. You have to show that they're congruent triangles first. Okay, number 2. We've got the givens and I've got a picture, so I'm going to go ahead and start with labeling my picture. That's the way that you would start a proof. And again, like I said, if there's no picture, then you would need to draw one. So it says E is the midpoint of BD. So what does that mean? What does it mean for E to be the midpoint? And so think about what is the definition of a midpoint? It means that it's right in the middle, right? So that would mean that ED is exactly the same as EB. It did not tell me that ED was congruent to EB. I knew that because I knew what a midpoint means. So let's keep that in mind, that this isn't actually a given. It came from what I know about a given. Okay, so E is the midpoint, that was given. I'm later going to have to state this in my proof. Okay, so I'm just going to hold on to that for a second. Okay, the next thing it tells me in the givens, it says that AC is perpendicular to BD, so that means that. It means that it's 90 degrees, okay? That's what that means, all right? So I'm going to write in the other given that AC is perpendicular to BD. That's my given. Step 3, and it says fill the blank boxes with the following statements or reasons. So these are my choices for the boxes there. And so with something like this, I'll give you enough choices to fill in unless there's actually a calculation, and then that may not be one of the choices. You might have to just fill in that extra box. So the next one, it says DE is congruent to BE. So how do I know that? Well, that's what I wrote up here. How did I know that? I knew that because of the definition midpoint. So you can just write midpoint definition. Okay. Actually, here's official. So midpoint actually can be abbreviated like that. I mean, you're just losing a couple words. And the actual abbreviation for definition is that. So you can write it like that. Okay, number 4, it says blank. So some statement. The reason for the statement is perpendicular lines form congruent adjacent angles. So what are two congruent adjacent angles? So if these lines are perpendicular, it's forming these two are the same, or these two are the same, or these two are the same, or these two are the same. Those are all true statements. Which one do I want to use? That's the question. And so look at what I'm trying to do. I'm trying to prove that these two triangles are congruent to each other. So it wouldn't help me to say that these two were the congruent angles. That's not going to be helpful. What would be helpful is if I said that those two angles were congruent. So I'm going to say those. So angle, not triangle, angle AED is congruent to angle AEB. Also, on a multiple choice proof like this, what I would do is I would go through and I would be crossing out things as I use them. Okay. Now, the next thing, it says something about a reflexive property. So knowing what the reflexive property is, it's that something is congruent to itself. Look at your choices. Which one of those looks like a reflexive property? It's going to be the AE is congruent to AE. That's the only thing that is there that's a reflexive property. So coming up here and marking it in my picture, let me just kind of clean this up a little bit. Here's what I know. I know that this is congruent to this one's congruent to this one, and this one's congruent to itself. So am I able to prove those two triangles are congruent now? And how come? Why can I do that? So the last statement, I'm ready to prove that those two triangles are congruent. So I'm going to say triangle AED is congruent to triangle AEB, and the reason is side angle side. That's what we've proven. Now, and I just want to show you this to show you proper use of Cpctc, because that really is something that people struggle with a lot. If this wasn't what we were trying to prove, but if instead we were trying to prove, like, let's say that AD was congruent to AB. Let's say that that's what we were supposed to prove. This proof would look exactly the same as it does, except for step number 7 now would say AD is congruent to AB. I've proven that the two triangles are congruent, but now I would say that the two pieces are congruent because of Cpctc. So if that was my goal, was to prove that those two pieces were congruent, then I would be using the Cpctc after I proved the two triangles were congruent. All right, let's go to the next proof. Okay, so we've got given, and it's a picture. So we're given what the picture says, and so you're going to have to interpret what those things are. So I see that these are the same, so I could say that angle A is congruent to angle D. That's given. I can see that DC and AB are congruent. That's given. I can see that angle C and angle B are congruent. That's given. And I also know that DM is equal to 10. Those are my givens. Okay, so looking up at my choices, let's see what I've got here. C and B, got that one. A and D, got that one. DM equals 10. Well, it says MD equals 10. Okay, got that. That's the same thing. And then the other thing was DC and AB were congruent. So I've marked out most of those. So the next thing that it says in the proof, it says, okay, the two triangles are congruent. You guys, why are the triangles congruent? What do I have? Well, it's got to be one of the 5 tests. It's got to be either side, 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 angle, angle, side, angle, angle, side, hypotenuse, leg. Which one is it? It's not hypotenuse, leg. It's not side, side, side. I don't know enough. It's not side, angle, side. I don't have 2 sides on both triangles. So is it angle, side, angle, or angle, angle, side? Well, angle, side, angle is the only one I know. Plus, you're kind of clued in because that's in the choices. Okay, so now we've proven that 2 triangles are congruent. Okay, I am trying to prove, so let's get our eye on the ball here. I'm trying to prove that AJ is 10. So I'm trying to prove that that's also 10. So that's what I'm going for. But now I know that these 2 triangles are congruent. So if I picked this triangle up and put it on top of this triangle, all the parts would match up. And so the next step is Cpctc. So what do I want to use from that? Do I want to say that MC is congruent to JB? Does that help me get to my goal? That's not what I'm trying to do. So what I'm trying to do is I'm trying to show that these 2 pieces are the same right here because that gets me towards my goal. So I'm going to say DM is congruent to AJ because of Cpctc. So that's that one. Now, because they are congruent, that means that AJ is going to equal 10. And the reason is because since they're congruent parts have equal measures. So I got that one, got that one. So a proof is just a series of logical steps, and you really have to think out like exactly what you know and make sure you've proven every bit of it. Okay, number 4, and then I'm going to put the rest of it on a separate video. But number 4, we're given that BC is congruent to DC, so that's marked right there. So I'm going to write that in my givens because I might as well. I know I'm going to have to. And then A is congruent to E, those 2 angles. So again, I know I'm going to have to write it down. And it's already marked in my picture, so that's good. I've got that. Now what I'm trying to do is I'm trying to prove that AB is congruent to ED. Okay, so think about how the other proofs have worked. If I was able to say this triangle is the same as this triangle, and so I could lay them on top of each other, what would match up? So I need to first say something about the triangles being congruent. Well, right now I don't have enough, but this has given us a clue. What else do I know in that picture? I know that angle, now you cannot say angle C because we don't know which angle C you're talking about. So you have to say angle, let's say ACB is congruent to angle ECD because of vertical angles. So now that I've got that, statement 3, it says triangle something is congruent to triangle something. So what are the names of the triangles? So A, B, C. And so if I go A to B to C, I'm going to have to go E to D to C. Okay, so you have to just make sure that you say it in the right order. And why? What congruence test of the 5 tests, which congruence test is the reason why? And so if you look, I've got an angle and a side. And so angle, angle, side. Okay, so now because the 2 triangles are congruent, what pieces are congruent? All of their corresponding parts are congruent. So what that means is it means that AB is going to match up with ED. And that's because of Cpctc. That's exactly how you would use that. Okay, I'm going to put the rest of this lesson on a different video so you can continue with that one.